The next mole conversion problems that we're going to do are moles and representative particles. Okay, so remember, a representative particle can be a molecule, which is abbreviated MO. It can be an atom, which is abbreviated AT, or it can be a formula unit, and that is abbreviated FU. So a molecule is going to be your nonmetal covalently bonded compound. Your atoms are your elements, or, Eve's husband. And formula units are going to be your ionic metal, nonmetal compounds. All right, so this is how we're going to convert between them. So it asks, how many moles is 2.107 times 10 to the 24th MO, which is molecules of oxygen gas. Oxygen is a nonmetal. So I'm starting with 2.107 times 10 to the 24th molecules of O2, and you don't have to write the of, and I want to know how many moles I have. And I would definitely star circle highlight this. MO is molecule, which are the teeny tiny little things, and MOL is mole, like the amount. All right? So please make sure that you don't confuse those two things together. Well, how do I get back and forth between a mole of anything and what we have? Well, that would be Avogadro's number, which 1 mole is equal to 6.02 times 10 to the 23rd molecules, atoms, or formula units. So this is where it's really important that you show your work correctly. And this is really important for how we plug things into our calculators. All right, so let's figure this out. 2.107 times 10 to the 24th molecules of O2. And then I make my conversion factor, and I have to place this correctly. Where do I put MO? Where do I put MOL? Well, if MO is in the top, I need to put MO on the bottom. 6.02 times 10 to the 23rd molecules of oxygen is 1 mole. The unit that you are converting to, meaning moles of O2, that unknown, that's what should be on top when you are done. Okay? And then when you put this in the calculator, this is the crucial part that we talked about last chapter, that you know how to convert them and put them in scientific notation properly. If you don't, I'll find out right now. 2.107 times 10 to the 24th is E24 times 1 divided by 6.02 E23. When you hit enter, what do you get? 3.5, excuse me, moles of O2. So sorry for sneezing in your ear, but I couldn't pause in time. All right, so what this does is this is going to show us how to get back and forth between our particles and moles. Our representative particles, again, are either molecules, atoms, or formula units on this graphical organizer. So that means that my molecules, atoms, or formula units are going to go in the denominator when I leave. And when I want to go to mole, I'm going to put 1 mole on top. When I'm leaving moles, I put 1 mole on the bottom and put 6.02 times 10 to the 23rd on top. Okay, so what do we get? We get our lovely 2.107 times 10 to the 24th as our given, so that goes here. And then we put our conversion factor, 6.02 times 10 to the 23rd, in the denominator, and we get 3.5 moles when we put it in the calculator correctly. The opposite is also true. How many atoms are in 12.5 moles of copper? So now I have 12.5 moles and I want to go to atoms. Notice it's not molecules this time because I'm talking about the element copper. So that means I want to know how many atoms of copper I have. The conversion factor is still Avogadro's number, which is 1 mole equal to 6.02 times 10 to the 23rd atoms. We are going to start with our given, 12.5 moles of copper, and I'm going to put 1 mole on the bottom and 6.02 times 10 to the 23rd atoms of copper up top. What cancels out? Moles and moles, leaving atoms, which is what I want. And how do I put that in the calculator? Just like I have taught you before, young Jedis. 12.5 times 6.02, E23, and then divide by 1. And what we get in our calculator is 7.53 times 10 to the 24th atoms of copper. So to see that all typed out for you, if you need to pause at any point, obviously you can do that. We're looking, given moles, looking for atoms of copper. It's still 6.02 times 10 to the 23rd. That is the conversion factor. So you identify the moles here and put moles on the bottom, leaving atoms at top. And then you put it into the calculator, 12.5 times 6.02, and you get your 7.53 times 10 to the 24th atoms of copper. Yes, you have to show the work. No, you can't just put it in your calculator, and you'll see why in the next couple of slides, because we're going to be using dimensional analysis all course long, and probably next year in physics and, in perpetuity after that. So these are mole representative particle problems.